Hello, hello, hello. Good afternoon, Internet. Welcome back. Welcome back to the same math time and the same math channel, right? Here we are again. This is the beginning of week 10. Week 10 of NL Mathman's Math Help Streams. We're holding it down here today. We've got a very nice picture in the background here that I took. I mean, you can see I'm sure there are hundreds, if not thousands, of pictures from this exact vantage point available on like Google image search or something like that. But this one is unique because this one is mine, right? There are many pictures like it, but this one is mine. It's a movie I haven't referenced yet. Boy, um, Kubrick. It might even be the first Kubrick one I referenced. Look at that. Yeah, do we have any guesses as to which place this is? I mean, we probably wouldn't need a ton of guesses, right? I mean, look at the bridge. Maybe not the bridge in the immediate foreground, but the one in the background at the very least gives it away a touch, I would imagine, right? But this location that we can see here behind me is of course London, right? London, England. The good one, not the knockoff discount London that's like in the middle of southern Ontario, right? Come on now. People say London, you're like, oh, you mean London, Ontario? I was like, no, no, I mean the good one. Not, anyway, not like the Zellers brand London in Southern Ontario. Anyway, um, yeah, I haven't shown many pictures from my, you know, city adjacent to my home away from home. Maybe I don't know. I haven't lived in UK for a while, and I never really lived in London. It was like half an hour outside London, right? Which to a Newfoundlander, like living half an hour away from a place is practically living in that place, right? Just because we're used to driving far. But then in like southern England, right, like half an hour's drive, boy, that's a long ways to go, right? Yeah, it's all perspective, right? But anyway, this is a very nice picture of London across the Thames, of course, looking at this Millennium Bridge there, all lit up in the purple and teal, etc. And then beyond that, we see London Bridge itself lit up with the white sort of lights across the support beams. Um, yeah, this would have been 2013. I think this was my in the first time I lived in UK, because I lived there twice, kind of, with a brief break in between. But this would have been my last visit to London before I came back the first time. But I did want to mention sort of my favorite place in the world, or definitely high in the running for it, that I found in London, which was Camden Market, right? And now it turns out I don't have any great pictures of the market. Unfortunately, I scoured through the pictures that I have. Maybe I'll find another one for next week's show and tell, right? I do intend to do some more show and tells. This is gonna be part two today, and I'm gonna be showing off a little thing that I got here, which is behind me. This is the sort of one of the entrances to Camden Lock Market. But this is the horse stables market, as you see by the rather large horse head there beside me, right? I did mention that I got an incredible pair of shoes here, but the object I want to talk about today, there's a bit of a story surrounding this one, right? So I like to go into all the different little shops, there, little boutique places where there's handcrafted stuff. That's really what I'm after. Some nice, unique, like handmade, I don't know, useful objects. And I like what I get to be useful as well, right? So I went into I bought a very nice leather jacket in Camden. That wasn't in the market though. That was on the high street outside, right? But then down into the market, I was going into a lot of these little shops that sold all these handcrafted leather goods, like belts and um, well, belts and bags mostly is what I was after, right? Like messenger bags or laptop bags or something like that. And I remember I bought one. I bought one rather. It was an okay, like sort of a black leather bag. It was fairly soft, and I figured I'd have a go at a bit of haggling, right? Because that's what you do. That's what you do when you're in a small shop, right? I can't remember exactly what I said now to haggle, but I do remember that the guy gave me £5 off that bag. So I was chuffed about that, as they say, right? That was enough to get me my lunch, right? So then I walked out with a rather nice sort of messenger style bag that I intended to use to bring my laptop back and forth to school in, right? Lo and behold, I get home after the day of being out in London. I get back to Surrey, and my laptop just barely can't fit in the bag. Like I brought a measurement with me. I brought like a piece of string that was marked like with the length of my laptop, but I guess I hadn't accounted enough for the thickness of the laptop. So it actually couldn't fit in that bag, and that sucked. That sucked, right? Like I paid 35 pounds, I think, instead of 40 for it. And I couldn't use it, right? That was really too bad. So then a week or two later, I can't remember how long it was now because I couldn't get into London every weekend. I went back in and I went back to the exact same shop and I brought the bag with me. And I said, I went up to the person who was there, and it was one of the same people that was there when I was talking about it. But I gathered this person might have been the owner, right? Because the person I talked to, I guess, was a salesperson, and this was another person who was there at the time. And I said, try to be really humble and really, I don't know, approachable, and said, I bought this bag here last week or 2 weeks ago or whatever it was, and it's, I really like the bag, but it's just not quite big enough for what I need, right? And can I exchange it for a different one? Right? I wasn't asking for my money back, just asking to exchange it. And then the guy said to me, "Well, what did you pay for it?" Right? And I thought, shit. Okay, what do I do now? Do I tell him? Do I say the 40 pounds, the actual price, that was the actual asking price, to try to bamboozle him about the 5 pounds less that I paid, that I haggled from the other guy? But no, I told him 35. I told him the 35, like a good boy, right? Like a little Boy Scout. And then what he did, well, he asked me what I needed it for, and I said I needed a bag that was a bit bigger for a laptop bag. And then he went, and this was a store like both sides of the store were just lined, completely lined with these really densely packed racks of leather goods, like bags and coats and belts and stuff like that. And then there were like three or four, yeah, three rows that were like parallel to the wall, right? And then so he points to the middle of like sort of the back middle of the very highest rack on like one of the sides of the store. Now I never would have seen this bag in. I mean, I could have been there in that store for 4 or 5 hours, and I guarantee you, I never would have noticed this bag first nor last. And it was the only one there like it, right? And it's some of the best construction I have ever seen of a bag like this. And this is it, right? So this is the bag that he pointed out to me. It's extremely solid construction. It hasn't like I bought this what 5 6 years ago now. I've used it every single day at work. I take this with me to work every day with a laptop in it and all my papers and stuff like that. It's no worse for wear than it was at the start. It's extremely durable, very very high quality bag. And like I said, it's totally unique. It was the only one there in the store like it, handmade, all that sort of great stuff. You know, genuine cow leather or whatever, right? And I never would have seen it, not in 100 years, if it wasn't for this guy pointing it out to me and saying, there, that's a good one, right? And maybe he did that because he knew I was honest about the 5 pounds that I had haggled, right? And then I paid the difference, and the difference was a fair bit. I mean, that was like an 60 or 80 pound bag. I can't remember, but yeah, I paid the full difference to it, and then there you go. Walk out with a bag that I've used basically every day since, right? Hey, Slayer Darth. Hey, how you doing? Yeah, welcome back. Good to see you again. How's it going? Yeah, it's going great. How about you? Ready to do some math learning on this Monday? The radio is a really good program right now on NLP, neuro linguistic programming. Okay, sure. Yeah, that sounds like a boy. That's quite a mouthful of a topic, isn't it? Yeah, what's that stuff about? Neuro linguistic programming. Is that kind of like repeating things in order to make them into a habit, or in order to, saying positive reinforcement, maybe? The first self-help book was written by a Scotsman called Samuel Smiles. Oh, that's a great name. Is that a pen name? Was that a pen name or his real name? Because like Sam Smiles, right? That's a good name for someone who's writing self-help books. Absolutely. Yeah. Anyway, after that brief show and tell, I think it's about time that I start in on some mathematics, probably, right? Like, I don't know, maybe that's what I'm here for. Um, Over here, there we go. I got it. I got it the first time. This time, look at that, just right there in front of me. Uh, Over there, you see the topics for today. We've got Venn diagrams, angle properties of parallel lines, introduction to Pythagorean theorem, and calculating gross and net pay. Um, yeah, I think, let's see. Calais, Renetta, and Evan needed those. If either of you are in chat, you can sound off and I'll get to your stuff first. If not, I think I'm probably going to start in with the angle properties and parallel lines. in absence of other recommendations. Right? Essentially, with NLP, you look at how successful people can do what they do. Okay, been practicing converting between different number bases. Oh, you mean like base 8, base 10 and stuff? Yeah, yeah, yeah. We don't get into that here. Although base 2 is obviously extremely important, right? Because base 2 is binary, right? I mean, even as a computer programmer, if you were to go on and do that, you probably wouldn't need to know a whole lot of binary off the top of your head. But it is still useful to know, why, say, 8-bit is 256, right? Stuff like that. Okay, so yeah, I'm going to switch over to angle properties and parallel lines first, I think. So Evan, that's going to be a topic for the section that you're working on. And I'm just quickly going to go over, let's see here. I had, yeah, Math at Work 10. Let me see here. Going over to my document display. Here we go. And we're going Math at Work 10. Yeah, these are the ones. These are the ones that I'm looking at here. Okay. So, Evan, one of the main reasons I wanted to bring this topic up is just because it's a really good example of the fact that teachers are sneaky and we're always trying to trip you up, right? Like, I mean, it's not quite that malicious. We're not always like actively trying to trip you up, but we are pretty sneaky. Like, I'm not going to lie. And because of that, you can't really trust the way that a diagram is drawn for any of these angle property questions, right? Like it might be tempting to look at one of these and say, hey, I can see that those lines look parallel, so therefore they must be parallel, right? It's not, I understand doing that, but it's not quite how it shakes down when we're actually doing it on a test or an assignment or something like that, right? So this is going to be Math 1102B, Unit 2. Okay, so now we're going to do 1A over here. In each diagram, are A, B, and C, D parallel? Explain using angle patterns or mathematical terms, right? So we basically have to use the diagram to explain if those angles are going to be parallel or not. All right, so I am on my paper here, I'm just going to draw these guys out as I go through. Right, and we know that if lines are parallel, so if lines are parallel, the angles around a single bisector will be equal. And what the heck does that mean? Well, here we've got lines BA Baracus, and DC, which I don't have a great character to reference. If AB and CD are parallel, then this single bisector, so this one line that cuts through both of them, so basically the angle here is going to be equal to the angle here, here is going to be equal to here, here, and here, basically the four around there and the four around there are going to be exactly the same. So how can we find out if they're exactly the same? Well, we're told that this is 42 degrees over here, and this is 42 degrees over here. Now, unfortunately, we can't break out our compass or a protractor and measure these ones because, again, right, when if lines are parallel, they travel in the same direction while never intersecting, maintaining the same distance apart from one another. Yes, exactly. Exactly. That is the definition of parallel lines, absolutely. And for the current unit that I'm doing, we'll basically have setups like this. They'll kind of look like the letter H a lot of the time, where we're trying to find out if these two lines are parallel, but what we've got is the same line cutting through two of them. So that's the single bisector here. Bisector doesn't necessarily mean that it goes right through the middle, at least not for lines, because of course lines are infinitely long, right? So a line can be extended as far as you want in either direction. So you'll never actually go through the middle of it. Or conversely, I suppose, if they're infinitely long, every point is the middle, right? Boy, that's mind-bending. That's true. So all four angles in each circle will be 42. If the lines are parallel, no, not quite. Not all four are 42. No, I see why. Yeah, I see why you might say that. But these are going to be equal one to another, right? So this one is 42, right? And we know that opposite angles across like that are equal, right? So this one's going to be 42. And we know that straight lines Straight lines make an angle 180, right? So we know that this one plus this one have got to be 180. So that tells us this one here has got to be 138, right? And again, opposite angles, sort of across sort of an x, are equal. So this is going to be a 138. And we can fill in the same over here, right? This is going to be a 42. This is going to be a 138. Yeah, exactly. 180 minus, yeah, 180 minus 42 equals 138. So that's how we got those ones. And then we have this one here to be 138 as well, right? And then we can say here, because we add them all up to check that they equal 360. Yeah, absolutely. Yes, that is a really good way of checking and making sure that you've done your work correctly, is going through and adding these guys to make 360. That's absolutely right. And then here, because the angles around a single bisecting line are equal, and these symbols here means line AB is parallel to line CD. Now, granted, that's a symbol for line segment, but I'm not, whatever. Well, we'll survive through that one, right? So then to show some other ones, let me grab some of my different colors here. Okay, so I'm gonna do question B. I'm gonna cram that guy in over here, right? Because this note in between still pertains to both of them. So question B, line there like that, line there like that, and a line here across. So this is a good one for showing, why the temptation to just sort of eyeball it doesn't actually work out for us, right? Because here we've got an angle that's 91 degrees and an angle that's 92 degrees. And then this is line A, B here, and this is C, D over here, right? So if I was to start going and start filling in as many other ones as we can get around there, for 92, we can subtract 180 minus 92 because they're a consecutive interior. Yeah, exactly. Right? So here I can do 180 minus 92 over here, right? And I'm going to get 88 for that guy, right? You're right. So that's 180 minus 92. It was 88 degrees, right? Then across here, this one can be 92, and this one can be 88 as well. Now for over here, we're not going to have 88, are we? We're going to have 89, 89, and 91. Right? So we can see here now that these angles are not equal, are they? Right? Because the way that we have to go about doing this one is 91, this is 89. Now, this is a bit difficult to see on the stream there, isn't it? But we can see that that's 89. This one here is going to be 89, and this one's going to be a 91. Because we can't sort of get ahead of ourselves and say that we can do like alternate interior or anything like that. We could do alternate interior if we knew that A, B, and C, D were parallel. But in this type of question, we're asked to determine, are they parallel or not? And here now we can see that they're not, right? Because it's only 1 degree in the difference, but 1 degree is enough, right? Because as we extend A, B, and C, D, as we extend them infinitely, they're going to cross eventually, no matter if it was 0.00001 degrees in the difference. Now, granted, we're not gonna give you ones that are that little in the difference, but if they're not exactly the same angle, then they will cross eventually, right? Right? So because the angles around the bisecting line are unequal, AB is not parallel to CD. Right? And we can see, say if we looked at, I'm not going to go through and do out like the full example for both these ones, but we can see over here, say for example, we know this is 38 degrees, right? So that means this one over here has got to be a 180 minus 38, which is going to be 142, right? So there had to be 142 over here where the cursor is right now. And since that angle is different than this one, that's 142, this one's 144, we know that A, B, and C, D are not parallel in that one. And we can do sort of the same thing over here, right? And another way to think about it is that we know that if A, B, and C, D were parallel, another way we can phrase it, if A, B, and C, D were parallel, then these two angles here need to be complementary, or need to add to 180. And if I was to take 84 and 97 and add those together, I'm going to get 181, right? Which is too much. This is more than 180. It has to be exactly 180, right? So over here as well, we know that A, B, and C, D are not equal. The next ones that I'm going to write out on paper, I would like to do question 3 over here, right? Because question 3, this one down here, is a bit more involved. So I'm going to go through and draw that one out for us. Problem like 1b, you can assume they're not equal to begin with, as you have two different angles. Is that correct? Sure. Yeah. You. I mean, you can't really assume anything is equal. You could say in 1b, you could say if they were parallel, right? Then this angle would have to equal that one, and since they don't, then they're not parallel. Is one way we could phrase it, right? But um, yeah, I mean, we could assume they were equal and then say this one plus this one and this one would be the same. Or for like in 1D, if we said assume they were parallel, then this angle plus this angle would have to be 180. Turns out it's not, right? Let's see here. So I'm going to draw this one out fairly large here because we're going to have a fair bit of labeling on this diagram to do. Okay, let me straighten up my. I think we're zoomed in a little bit too much there. There we go. Yeah, that looks a bit better. Okay, so this is going to be AB here. This is going to be CD. This is going to be E and oh, tell you what. How about I zoom in a whole bunch over here, and then there we go. Perfect. Perfect. Now we can see it a little bit bigger. Hey, EF, there like so, and then GH here like this, and then IJ over there. Okay. Now, what angles are we told? Well, we're told this one here is 90, so I'll put in that one. So it's 90 degrees. Don't really need to label it as well, right? Just because the corner is enough to show that that's 90. And this one here is 90. This angle here is 89 degrees. This angle here is 92 degrees. Right? Now, I'm going to use a different color here now to show that I'm filling these ones in after the fact. Right? So all the stuff in green was what we had from the get-go. I'm going to start filling in red now to show the things that we are determining. Right? So we know that if this angle is 90, well, we can determine that all these other angles here, this one has to be 90, this one has to be 90, and this one has to be 90. Right? How can we do that? Well, we know that these two together have to make 180, right? So this one has to be 90 as well. Then by the same property, we can get all the rest of them. There's loads of ways we can do that. And by the same token, this is 90, this is 90, and this is 90. So here what we have, EF, we can look at EF as our single bisector. So that's one line that's cutting through both GH and IJ, which tells us that GH and IJ are indeed parallel. Right? So because of the red stuff I've written there, we know that GH is parallel to IJ. Right? So, right? So due to the red angles being equal, these ones down here, we know that, and we can phrase it in a lot of different ways, right? But the bottom line is that all the lines, all the angles around this are all the same as the angles around this, right? So, another way we could phrase it is that the angles around bisector EF are equal, right? So we know those two are indeed parallel. So let's fill in some more here now. What can we figure out about these angles over here? These guys, right? Well, we know this one's 89. So if we know that one's 89, this other one has to be 180 minus 89, which is going to, of course, be 91. So we know this angle here is 91 degrees, right? We know this angle here is going to be 89 degrees, and we know this one over here is going to be 91 degrees, right? Then there's loads of other ways we can get these ones, of course, right? Let's say this one here has got to be 92 because it's directly across from this 92. This one here is going to have to be 88 degrees, and this one here is going to have to be 88 degrees. Like so. That's right. Yep. So now, hmm, right? So now we've got this line CD going through GH and IJ. And yeah, that's a little bit odd, isn't it? Because this now seems to be indicating to me that GH and IJ can't be parallel, right? But if these ones here are the same, hmm, that's odd. Does that mean that CD then is not a straight line? Well, I guess that's going to be going to have to be what it means, isn't it? Right? Because if this single line EF can go through here and have all its angles the same on both, well, that means that this angle, this line is going through straight, and that all these angles are the same. So GH and IJ have to be parallel because of that one. But if we look over here now all of a sudden there's one line going through where the angles are not equal. So I think, maybe I should have checked this example before I went and did this one. But that seems to imply then that uh, line CD is actually not straight. It's a bit odd. This one is a bit of an odd question, isn't it? Doesn't look like any of the lines are parallel to each other. Um, yeah, this is a very odd question, isn't it? Isn't it? Um, it looks to me like a lot of these lines can't be straight lines though, right? Because if this is 90 and this is 90, which we're told, then all of these have to be 90 and all of these have to be 90, which means it's got all the same angles around this shape here, right? And if we go over to here and look at G, say for example, we know that this one here is 90 and this is 90 and this is 90. So if we look at these two pairs here, this is parallel. All these angles are the same as all these angles, which means EF is parallel to AB because of those. But here we have, but CD is starting to mess us up. Hmm. This is a really, boy, this is the, in 44 streams, this is the first time that I have actually had a question come up in one of these math units that's throwing me for a bit of a loop here. Right, because if all these angles are the same, and all of these angles are the same, right? Then there's one line coming through here. Then these two, the AB and EF, have to be parallel with each other. Yeah. I mean, this one does need to be parallel with this one because all the angles around here are equal to all the angles around here, and this is just the same line cutting through both. And I'm not entirely sure how this can happen in a real space. Which lines are parallel? Which lines are perpendicular? Give reasons for your answers. Yeah, I think that the answer here, um, unfortunately, is going to be that line CD is actually not quite a straight line, right? And that it's possible. It's possible that if CD, but as soon as we can start saying that these lines are not quite straight, then the whole sort of way that we solve these questions just goes out the window. Well, not for this one. This one still works, and then this one still works. That's no, that's true. That's true. No, it's yeah. It doesn't really go out the window. No, it doesn't. Does it? No, it doesn't. That's right. So yeah, so if line CD is not quite a straight line, that can result in this being the case while the rest of these are still parallel. Okay. So I think we got there in the end. It's maybe a little bit different than what I had imagined this question was going to show, right? It's not quite the conclusion that I wanted to get to here. But yeah, that's what it's going to have to be in order for those to work out. Anyway, maybe it wasn't the most straightforward of examples that I could have chosen. So tell you what, Evan, tell you what, I'm going to finish off this section here now by showing the example from the review sheet that I believe. Let's see, yes, the one that I wanted to mention specifically was this one over here, number 10. All right, so let's zoom in, and then let's do this one, and then that will show you a bit about what I actually meant to cover here. Boy. So this is math 1101B. Didn't realize separated lines could still be parallel. Yeah, well, sure. Sure, yeah. Yeah, no matter how distant they are from each other, they can still be parallel so long as they have exactly the same angles, which means if we extended them infinitely, they would never cross, right? Like, say, in this one that I've got over here on the side, right? Say line GH, right? We've seen this. Line GH can indeed be parallel with KL, even though there's this IJ in the middle, right? So imagine we left IJ out. This one here could still be parallel to this one over here. It definitely seems like sort of BA and CD ain't going to be parallel, right? It sure looks like it. But let's copy out this example then, and then see where we get to before we're done. Okay, so we've got AB, we got CD, DF. What? Why are they using the letter D twice? That's really unfortunate. Yikes. Hmm. G H I J and K L. So this is supposed to be an E here. I'm gonna go ahead. I'm gonna go ahead and say that that was a typo. That was just an easy mistake. Somebody accidentally put the wrong guy in up there. Right, so we know this is 107 degrees. This is going to be 73. This is going to be another 107. And this one here is going to be 106. And we've got this one here to be 106. This one here to be 73. This one to be 73. This one to be 107. Boy, okay, there's a fair bit to write down. Okay. And what are they asking? Given the diagram below, which pair of lines are parallel? And explain your selection. Now, we might be tempted to look at this and say, well, um, you know, just sort of glance at it and try to figure it out from just the way it looks, right? But what we actually had to do is we had to go through and we had to figure out these by filling in as many other angles as we can, basically, and then we can use that to kind of determine which ones are equal and which ones are not. So, for example, well, let's take the top left first. Let's start going from this one, right? We have, we know that this one here is going to be 73. Thanks, Layer Darth. We do know that one. Although you did 180 minus 73, that's true, right? So that would give us this one down here being 107. That works. And to focus on this guy up here, right? We know that this one here is going to be our 107. And this one here is going to be 73. So now let's check the other lines, or let's check the other sections where this same bisector goes through, right? So this was a 107 and 107. This is a 106, which means this one here is going to be a 106. So we know that GH and IJ are not parallel, right? Because we've got our single bisector here, and these ones, this point is different than that point. So we know now that GH is not parallel to IJ. Help if I finish my letters. GH is not parallel to IJ. Okay, so we've got that. Now going through here, we know this is 107. So this is going to be 107. This one's going to be 73. And this one's going to be 73. So because we've got a single bisector, AB, here like that, and then GH and KL, right? Around those lines, all the angles here and all the angles here are the same. So from this now, we can say that line GH is parallel to line KL. So we can say that one based on what we know from those angles, right? Let's do these next ones. Fill these next ones in blue. Let's go over here. So we know that one's a 107. This one here is going to be a 107, and this one here is going to be a 73, right? Like so. So now what we're trying to do is we're trying to figure out sort of the top and the bottom. So right now we've figured out the three horizontal ones already. That was these ones. Now I'm going to try to figure out the vertical ones, basically, right? And so if we look at, say, here's line IJ, right? We see a line IJ cutting through here, and then we've got line AB and CD. We can see that this is 74 degrees, and this one here is 74 degrees. We're getting pretty densely filled in here. But because the angles around this point, right, 107, 74, those aren't the same, obviously. 73, 106, those aren't the same, obviously. We now know that AB, so this one coming down here, is not parallel to CD. Now that one might be, come on now, stop being so dark. That one might look fairly obvious, right? But we still had to go ahead and say it because of those blue angles there like that, right? So let's go in and start filling out this last one over here now. So we've got our 73. So if this is a 73, we know this is a 73. And we know this is going to be 107, and this one's going to be 107. Ah, okay. Now, line FE, or EF, rather, we see that all the angles around this point are the same as all the angles around this point, right? So because of that, then this tells us that line EF is parallel to line AB. Sort of the green ones that I've done here and these ones over here, right? We'll go ahead and tell us that those ones are going to be parallel as well. So that's really all we're doing here, is determining which of these lines could possibly be parallel. Now, this question on your review sheet, Evan, doesn't ask for perpendicular. So that one I was just doing out of the book did ask for perpendicular, but I never got around to that just because, the one that we're talking about here didn't, right? Perpendicular means that they would cross at exactly sort of 90 degrees. Do all the bisecting angles on the lines have to be equal? Well, kind of what has to be equal is if we look at a given point, right? So basically what we have here, if we look at line KL, which is coming across here, right? So it bisects lines AB, it bisects line CD, and it bisects line EF. if all the angles around this point, say, are the equal to all the angles around this point, then we can say line AB and line CD are parallel. But they're not going to be. Um, Not all the bisecting angles are necessarily equal on GH and KL, but they're all equal if we compare this one to this one. If we compare the ones along the same bisecting line, then they are equal, right? So like this angle here, right? This one equals that one. And this one equals that one. This one equals that one. And this one here equals that one there, right? So say for this point, this and this point here, all those angles are going to be the same. And if we were to be able to figure out, say this one is going to be equal to that one, the same as this one's equal to that one, and this one is equal to that one, right? And that's because GH and KL have exactly the same slope, right? So another line that crosses through both of them meets both these lines at the same angles, right? I hope that makes a bit more sense for you. Yes, and Evan, if you've seen this one, I hope that sort of makes some sense as well. But to give you full marks on a question like this, I would need to see basically you indicating that you found all the other angles around these points. Are you focused on just the given transversal? Yes, exactly. Yes, that's right. Yeah. So for the given transversal here, right, all those angles and all those ones are going to be equal. That's right. Now, I did mention that I wanted to briefly get into, let me see here, back on the intro. Stream starting soon. Well, nope, we're going. I mentioned that I wanted to get into Introduction to Pythagorean Theorem. And I would like to carry on right now with that one because, Evan, that is the topic in the next course that you're on to, right? I don't want to be like loading you down with too much stuff all at once, but I do want to sort of work a little bit ahead of where you're at, maybe give you a bit of intro to what it's going to be like, right? So Pythagorean theorem. I'm just going to pop over to a website here now. This one is Math is Fun, right? Because it is, because math is obviously extremely fun. I mean, I think so anyway. That's what matters, right? So down through here, this is Pythagoras' theorem. They call it the Pythagorean theorem. One reason I wanted to show this is just because it's a good example of what's actually happening when we're dealing with the Pythagorean theorem, right? So down here, we can see that there's a right triangle that we've drawn. And if we draw a square where each side length is the same length as one of those sides of the triangle, we're going to find that the two smaller squares added together makes the same as the bigger square. And this sort of this property of triangles is fundamental. Like so much of the math that we do in these courses, and a lot of extremely useful and practical and very important math extends from this simple observation. I mean, simple in retrospect. For Pythagoras at the time, it was not simple, but that's just, if we can see further than others, it is because we're standing on the shoulders of giants, right? To quote Isaac Newton and the quote on the, I believe, 2-pound coin around the rim, I think. Yes, thanks. Thanks for that. I'll check out that book afterwards. Yes, thanks, Laird Darth, or that page that you linked, rather. I will indeed check that one out. Yeah, I just wanted to show this one here because it's a good example of sort of what's going on, right? The square made from the side A, or the smaller side, combined with the square from side B, the other small side, equals the square from side C. And that's the root of, we get sine and cosine waves out of this, right? Like ways that we model sound waves come from the fact that that these triangles relate in this way. It's really incredible just how much math is built on this observation from a Greek mathematician, 2,400 years ago or whatever, right? It's pretty amazing. But if we go back over now, I'm going to show. Let's see here. I will briefly show Method Work 10, page 290. Yeah, here we go. So this is in your book, the way it starts talking about it, right? And in your book, I'm just going to show you here one issue that sometimes comes up in this unit of the book is that people are sometimes a little bit confused as to what it means when it says to estimate these. Like you notice here, it says estimate the side of this triangle, right? Um, just for estimating, I mean, you can just use Pythagorean theorem to give the best guess, right? But we know from the Pythagorean theorem that the hypotenuse, or the middle line of the right triangle, like that, always has to be the biggest measure of the right triangle. It'll always, always, always be the case, right? Like if we look back over to the math is fun one that we were just looking at, this relationship only works, right, if the one that's by itself is the biggest side. And this is what we call the hypotenuse, right? It's the side that is opposite the right angle in the triangle. And this side here, C, is always going to be the biggest side. So if we flip back over, that is sort of what this very first section on right angles or Pythagorean theorem is testing. I do like this picture, though. Look at that. Lansing Meadows. I don't know if you guys have been to Lansing Meadows, but it's fantastic. It's a long drive. It's a very, very long drive, but it does. It looks exactly like that down there with the recreated Viking settlement, right? Pretty cool. But for your first section, it's basically just testing, do you realize that the hypotenuse needs to be the longest side, right? So for an estimation, you could say, well, this is 5 and this is 8, so this has to be bigger than 5 or 8, so maybe this is 10, right? And that's all you need to do for the estimation part. But what I'm going to do is I'm going to go ahead and do some calculations just to show you how we would actually calculate it. So maybe I'll pick a few of these first, then I'll do a few word problems, and then that should probably be plenty to get you started on this unit, right? So this is going to be math. This is 1102C, unit 1, right? And I'm going to do, this is going to be page 288. And I'm going to do question 1A. Well, my estimate, like I said, I'm going to estimate 10. Just because my estimate needs to be bigger than either of those sides, right? But I'll just draw out the shape here. Say we cut it in half, right? Because we're looking at the dotted line through the middle of that shape. So that's going to be 5 feet there, 8 feet there, and some unknown. I'm going to call that C over here, right? So we know that we have to use our Pythagorean theorem, which is a squared plus b squared equals c squared. Or, just like we saw back over on our Math is Fun tab, right? The way that that's shown is a square that's made from this side plus a square made from this side equals a square made from this side, right? So we know that the A side over here is going to be 5. So this is going to be 5 squared. The B side down here is 8. And the C squared, that's the one that we don't know yet. So now we're going to go through and figure these ones out. Well, I happen to know that 5 squared is 25 and 8 squared is 64. But of course, your calculator is perfectly capable of telling you those. Then if I go ahead and add these ones together, I'm going to get 89 equals C squared. And now what do we do, right? Well, for this unit and for most of the math that we are doing here, you're going to be just getting a decimal value for those ones, right? So now you got to go over to your calculator and you've got to find your square root button, right? Because the opposite of squared, I'll show you that now, opposite of squared is square root, which is that symbol. Right? Now in Betty Ann's current course, I was sort of explaining a bit more about why that's the case. Evan, your program is not really going to get into a lot of the properties of radicals, but I'm still going to go through and show a bit about how we're going to calculate these guys, right? So root of 89 is just that, root sine 89 like so. So 9.4 equals C. Right? That's all we got to do for these guys, basically. Right? Estimate the length of each hypotenuse by rotating the longer leg of the triangle. Oh, whoa, that was not the window that I wanted to move that in. Okay. But estimate again, right? Like, it's all roughly the same for estimating. All it's got to be is a bit bigger than the other ones. Right? So I'm not going to go ahead and... well, actually I am. No, Scratch that. I am going to go ahead. I am going to go ahead and solve this one. 65 feet, and this one's going to be 50 feet, right? And we're going to call this one C because that's our unknown. But that one's we know that this is the right angle. So C is always the one that's opposite the right angle, right? All right, so in the Pythagorean theorem, C is the side opposite the right angle, or C is the hypotenuse, right? So then we've got A squared plus B squared equals C squared is our Pythagorean theorem, right? So my estimate, right? I've just got to estimate a number that's bigger than either of the two that are there. So let's see, we've got a 65 and a 50. I'm going to estimate, I don't know, 110. This is a number totally picked out of the air. Whatever, right? So we're going to have 65 squared plus 50 squared equals C squared. So now, I don't know those ones off the top of my head, so I'm going to break out my calculator. 65 squared is 4,225 plus 50 squared. It's probably going to be 2,500. Indeed, it is. 2,500, that's going to equal C squared. So then 6725, 25 is going to equal C squared. So then the root of 6725 equals C. Root of that answer, that's going to give me 82. Okay, so my estimate was way off. It was way big, right? But that doesn't matter. In your courses, that would still be totally correct to have 82, sorry, as 110 as an estimate. Because all I'm looking for in an estimate is that you show that you understand that it has to be bigger than the other sides. That's it. But then eventually you are going to have to go on to calculate them, which is why I'm sort of explaining it in this much detail here instead of just picking a bigger number and moving on, right? So this is going to be, I'm going to go on and do page 290. And this is going to be question 5, here like so. It says Nadine wants to clean the windows of her house. She estimates that the tops of the windows are 9 feet above the ground. Places the bottom of an extension ladder 3 feet from the base of the house. Estimate how long she needs to make the ladder. Okay, so I generally do recommend drawing out a diagram for each of these ones, right? But that's just going to be our rough little diagram there. Just again using my triangle stencil. So this is going to be 3 feet here on the base, like it shows on there, and then 9 feet up there. So how long does our ladder need to be? Well, we know that's a right angle, or at least we would hope so, seeing it's the corner of a building. If it's not a right angle, you know, maybe she's putting a ladder on the Leaning Tower of Pisa or something, right? Which we wouldn't be able to use Pythagorean theorem for that one. We would have to get the angle and then use cosine law. Hey, you know, that's a thing that other people are working on. But here now, just going to do 3 squared plus 9 squared equals C squared, or 9 plus 81 equals C squared, 90 equals C squared, the root of 90 equals C, and then the root of 90 is going to be what? Well, let's find out. Root 90, about 9.5. Right? Good stuff. And let's see. You know what? No, that's probably good for now, I think. Right? Evan, I will send you those as notes there now in a bit. So that will be sort of an introduction to that unit for you. Switch back over to my intro. So that was the two middle ones. Yes, Venn diagrams and overlap. I do need to get to that one. Yes. Okay. Because Calais asked for that one specifically. So I'm going to get that one done as well. Calais, if you're there in chat, You can let me know if you have any questions as I'm going through. If not, I will, of course, send this to you. And so you may be watching this in the future, in which case, yeah, I hope it helps. And just send me another email if there's anything else that you want me to get to for this one. But to start off, I'm going to be going to page 53. Let's see, page 53. You know what? No, I'm not going to do that one. I'm going to go to page 58. Here we go. Here we go. Okay, perfect. So this is going to be Math 3101A, and this is going to be on Venn diagrams. Now, let's see here. So I'm going to do questions 5. I'm going to start off, well, I'm going to start off with question 5. Let's zoom on in. Zoom on in, move it over. Okay. Yeah, these are fairly good. I think these are fairly good ones. So let me now go back over. Let's go over to the working display. Okay, so for question 5 then, so this is page 58. And this is going to be question 5. For this one, teenagers at a summer camp are asked to choose an activity. 28 want to go canoeing, 45 want to go swimming, 20 want to do both, 11 do not want to do either. How many teenagers are at the camp? Okay? So in general, whenever we have a Venn diagram question like this one, what we're going to do is we're going to start with drawing the number of circles that we have. Now for our courses, we're only going to be dealing with either 2 or 3 circles in these questions. Because as soon as we start getting to 4, you've got to actually make sort of like an oblong shape so that all the different sections are accounted for visually. But as long as we're doing 2 or 3, it works out a little bit more simply. So we are going to be doing that, right? So we know that the number of canoeing is going to equal 28. We know that the number of swimming is going to equal 45. We know the number of both canoeing and swimming. That one is 20. And the number of canoeing or not canoeing or swimming is going to equal 11. So 11 don't want to do either, right? So this is the number of not canoeing or swimming is going to be 11. So canoeing and swimming. Well, where's that going to go? This is going to be canoeing here. This is going to be swimming here, right? So the number, we always start in the middle whenever we're filling these ones out, right? So the number of canoeing and swimming is going to be 20. So we know that here in the middle, we're going to put in our 20. And Kelly, I know I'm not answering the exact question that you asked me, but this part here is really important in answering a question like the one that you asked, right? Is that we have to start with the middle first. Okay? So now we know that the number of canoeing in total is going to be 28, right? So, but there's 20 already represented here, and this full circle has to make 28. So we know that this part over here is going to have to be 28 minus, throwing in some set theory. Yes, exactly. That is what we're off onto now. That's right. So 28 minus 20 is going to be 8. So there's going to be 8 over here, right? By the same token, this whole circle here, we're told that the number of swimming has got to be 45, right? So what's got to go out in this section? Well, that section is going to be 45 subtract the 20 in the middle. That's going to be 25. So we know there's a 25 out here. And we were told that there were 11 teenagers at the camp that didn't want to do either. So the 11 will go here on the outside, right? So how many teenagers are at the camp? Well, that's going to be number of total, right? So our number total is just going to be going through and adding up these ones. It's going to be 8 plus 20 plus 25 plus 11, right? So that's 28 plus 25 is 53. 53 and 11 is 64 teenagers at the camp. Right? Okay. tell you what, I'm gonna skip. I was gonna do number 6, but I think I'll skip number 6 because number 7 here. Number 7 is much, much, much more like the question that you were asking me specifically. So I'm going to get on and do question 7 here. Right? Actually, let me zoom out a little bit. Okay, so this is going to be question 7 down here in blue. So grade 12 students at a high school were required to take at least one of physics, chemistry, or biology. Okay, so if they had to take at least one, we know that there's not going to be any numbers outside like there are over here. We know 37 took physics. Okay, so the number of physics is going to equal 37, right? 62 took chemistry, so the number of chemistry is going to be 62. 68 took biology. The number of biology is going to be 68. 27 took physics and chemistry. So the number of physics and chemistry is going to be 27. We know physics and biology is 15, so the number of physics and biology is going to equal 15. We're told the number of chemistry and biology is going to be 33. And we know that 12 students took all 3 classes. Okay, so all 3, we're going to represent that as a number of physics and chemistry and biology equals 12, right? In the order of importance of those sciences to the natural world, obviously. Hot takes, right? That's what you come here. That's what you come to NL Mathman, twitch.tv/NL Mathman for, is hot takes about which science is more important than the others. The actual truth, which science is the most important? Well, it's culinary arts. That's what's the most important science of all right? That one trumps the rest of them. Because if you didn't have delicious things to eat and drink, well, what's the point? What's the point of the rest of them, right? So that's for the record. The most important science is cooking. Although it does have the word arts in there, right? Like, how dare I say an art is a science? But cooking is science. Cooking is science, and it's art, and it's history, and it's geography, and it's tradition, and it's everything. It's just everything about living and humanity all rolled up into one, and then you eat it. It's wonderful. Anyway, so I'm going to draw out the Venn diagram. I said that is exactly what we're doing here. Most important science was computer science. Well, that's true. Actually, yeah, that's otherwise how would we watch my streams? It's a good point. That's a really good point, Sawyer Darth. Yeah. And also, like, how would all of us be able to exist in this computer simulation that we're surrounded by if it weren't for the computer science of the parent universe that created our simulation, right? This is we don't need to get into that, but I do find that whole simulation hypothesis to be a very fun sort of thing to banter about. For the record, it's totally like verbal, just shit posting, really, right? Like it's just nonsense, but at the same time, it's fun nonsense. So the number of P and C and B is where we have to start with, right? We always start with the number in the middle. And this, Calais, I know I'm sort of bouncing around a bit here, but this is the real meat of answering those questions like you have asked, right? Is that we have to start in the center. So we know that the number of all 3 of them is 12. So we know that this one goes right in here. So now how are we going to figure out the rest of these? Well, we know that, I'm going to go from the bottom up here. We know that the number of chemistry and biology is 33. So does that mean that I just take a 33 and I put it in here because it's the number, because this is chemistry and biology? No, I don't. I can't just put 33 there. You know why? Because the chemistry and biology section is not just this area. It's actually this full sort of oval, almond-shaped area, right? So we know that the 33 has to be these two put together. So this one here is actually going to be 33 minus 12 equals 21. So we know that this one is going to be a 21 right here, right? And we found this 21 by doing this number, subtract that one. By the same token, we're going to have to do that for all the other ones too. Physics and chemistry is 27. Well, 27 minus 12 is going to be 15. So we know that a 15 has to go up here, right? Sort of the same way that this one here, number of P and C equals 27. Number of P and B equals 15. So P and B is this full section over here. So what goes in there? Well, it's going to be 15 minus 12 equals 3. So we're going to put a 3 over there, right? Yeah, how's about, just so when you see this, it's a little bit clearer, I'm going to do a little color coding here so that we can see how these three sort of correspond, how the workings there correspond to what we're doing over there, right? So Kelly, if you're watching this now, you know, the circling is just sort of to show you where those bits are coming from, right? And then by the same token, say we know that the full chemistry bubble, all of these ones out here, all of this put together for chemistry has got to equal 62 in total, right? So we know that the number we're looking for is going to be 62, subtract 15, subtract 12, and subtract 21, which is going to be 62, subtract 27, 40, 48. So that's going to be then 14. Always start with the number that compromises all the options or interests. Yeah, exactly. That's a great way of saying it, for sure. We start with the one that affects the most. So we're sort of starting in the middle there, right? This one here is going to make 14. Because we know that the number of chemistry is 62, right? So we know now that this one out here has got to be the 62, subtract this, and subtract this, so that all of these ones put together get us our 14, right? The same sort of deal for P over here, right? This one is going to be 37 minus 15 minus 12 and minus 3. That's going to equal 37 subtract 30. So it's going to be 7. So over here, it's going to be the black 7. Down bottom here then for B. But, I think you see where I'm going with this now. It's going to be 68, subtract 3, subtract 12, and subtract 21. So that's going to be 68, subtract 15, and 21 is 36. So that's going to be 32. So there we have it. And then how many students were in grade 12 this year? Okay, so now to get the number total is just going to be all of them added together, right? So the number total is going to be our 7 plus 15 plus 14 plus 3 plus 12 plus 21 and plus 32. So then n total is going to give us, see, 7 plus 15 plus 14 plus 3 is 12 plus 21 plus 32, 104. Just to show that that goes down here with this one, right? So that is then how we would find the number total in the end. And it all stems from the fact that we had to start sort of in the center and then going to radiate out in order to see all the bits that we needed to figure out, right? Okay, yeah, Kelly, I know that was just 2 examples for your questions, but hopefully that explained those fairly well. So I will send this off to you now shortly. If you're watching, you will get a copy of these notes shortly. Now let me go back over to my intro. the last topic that I had to talk about today, I'm going to be calculating gross and net pay. So that one is for Renetta. I'm just going to quickly go over the specific one. Let's see here. Yeah, just give me half a second, or perhaps 10 seconds, and I will um, bring up the actual activity that we were talking about earlier. Oh, right. Yes, I actually haven't. I've been writing it up. I haven't sent it off to you yet. Right. Okay. Um, I'm just going to walk through this one here, just so you can have an example of the working being done. Now, when I saw you um, doing this one, could have done with a math teacher like you back at school. Oh, thanks. Yeah, that's very nice. Very nice of you, Slayer Darth. Yeah, I appreciate that. Hey, there's always whatever schooling you do in the future. Let me tell you, there's always going to be some good teachers that you find, because say if you go on to a university or a college or something like that, right? Like at a university, teachers tend to be hired based on their subject matter knowledge and not necessarily based on their teaching skill per se. But some of the best teachers that I've had at university, because some of them are um, very motivated to try to figure out the best ways to teach and to sort of add that on to their great experience in the subject matter as well. So I think there's probably a lot out there that'll help you out a great deal if you decide to pursue your studies further, for sure. So Renetta, yes, I just wanted to go walk through this one quickly. Um, it seems like you were doing all the work correctly, and I'm not entirely sure where the mistakes were coming from, because you made several here. Your workings were really good, what you wrote down, but some of the numbers just didn't match. And I have a feeling there might be one small thing you're doing with your calculator that you're just doing it a little bit wrong each time. Maybe you're just punching in a button wrong or something like that, because everything you wrote down was right, but then some of the numbers that you got from it didn't quite work. Right? So I'm just going to show you how we would go about figuring out the total deductions here for question 11. So this is Math 1102B, and this is Unit 1. I'm going to do this question number 11 here, right? And this is Alex's gross salary, 45,350. So his total salary, or gross, is going to be 45,357, like so, right? So use the following deductions to answer the questions, right? So we're gonna take those as his deductions, and we're gonna figure out his actual gross salary. Okay. So federal income tax is going to be 15% of gross pay. So how are we going to represent that? Well, we're going to represent that as 45,357 multiplied by 0.15. That's how we're going to find 15%. Right? So we're going to do in our calculators 45357 times 0.15. That's going to be 6803.55. Right? We're going to do the same thing for provincial. Provincial taxes 7.7%, so that's the same total amount, times by 0.077, and that's going to equal 3492.49. Right? Our CPP, well, that one's going to be the same amount multiplied by 0.0495. 45357 times 0.0495 equals 2245.17. But we know now, right? We see over there on the side that this is over max. So we're going to use 2163.15. And then EI, well, if CPP is over max, you have to use a calculator for this unit? Yes. Yes, Slayer Darth, they do indeed. Right? You get to use a calculator for all these units. B is going to be 45,357 multiplied by 0.0173. I mean, figuring it out without a calculator is totally possible, but boy, that's a lot more number crunching for sure. 45357 times 0.0173. That's going to be 784.78. And again, that's over max. $747.63. Right, so then total deductions. Is of course just going to be all of those added together, right? So it's going to be 6803.55 plus 3492.49 plus and plus. And we hit enter. Do it without a calculator, but it takes up a lot of space on paper. Yeah. Yeah, absolutely. I mean, all that multiplication, you absolutely could do it by hand for sure. It would take a lot longer and a lot more space. But yeah, it's just a lot of number crunching, a lot of long multiplication, right? So his total deduction is going to be $13,206.82. And his annual net income, well, we know that net is equal to gross minus deductions. Right? So in this case, it's going to be 45357 minus 13,206.82. And we don't need to mind with significant figures and stuff like that because these are money, dollar values, right? None of these are measured quantities. Oh, that's kind of a message for other students. So Renetta, I don't think you've seen significant figures yet in these courses. And there we go. That's all we got to do. That's all we got to do to get a question like that one. If he was paid biweekly, what does earnings be for one paycheck? Okay, so then his biweekly pay remember, biweekly means divide by 26 because there are 52 weeks in a year, right? So that's going to be 32,150.18 divided by 26, and that's going to give us 1236.55. There it is. That's his biweekly net income. There we go. Now the only other issue that people tend to ever have with questions like this is not including vacation pay. Now, here we go. Use the following rates to determine Lisa's net pay for a week of work. Now this was another question on the same activity. I don't think I'm gonna work down through this. Yeah, so the only difference for this one here, right? Just so you know, and I'll write this down on here, but I like I said, I don't think I need to work through this other example because it's very similar. But vacation pay so it's one other little blurb to remember. Right? So once you've taught this course a few times like I have, or as many times as I have, you start seeing that, students are losing marks kind of from the same few little easy mistakes, right? Because the general tentpoles of how you do this stuff is relatively straightforward, and people are pretty used to the notion of, net pay versus gross pay and stuff like that. right? But one of the small places where people tend to lose marks is sometimes forgetting to add vacation pay first. So, for example, for Lisa over here, if we wanted to find out her federal income tax, what we have to do first is do 1045 and then add our vacation pay by doing something like this. We find her total pay is actually 1086.8, right? It's only 4%, but it does matter. And let me tell you, the governments, they're going to take their cut. They're going to take their cut of that vacation pay just like all the rest of it. Then we're going to find times 0.15 like so. And her federal income tax is actually going to be $163.02, right? Because it's 15% of her pay with the take-home pay added. But anyway, Renetta, I hope that helps you out for that one a little bit. So, I think we have come once again to the end of our stream, basically for now. I am going to leave you guys with a little reminder. Here's my show and tell item for today. Maybe I'll review this very nice leather bag that I purchased in Camden Market in London, right? And I it's a good moral lesson for myself, to even if you're gonna haggle, if you're gonna at least be honest. Be honest with people afterwards, and honesty is rewarded, right? So honesty is the best policy, unless you're an American politician in 2020. Anyway, I'm not. Oh boy, no. I can't get into that. Cannot get into that. Okay, before I say anything more inflammatory, I am going to log off for the day. Thanks for being here with me. Thanks for doing some math. I hope it's been entertaining and engaging and informative. Uh, or at very least, not sleep-inducing. Stay safe. Shouldn't have let you leave, to be honest. Too valuable an asset. Oh, well, thank you. That's very sweet. Well, maybe I'll be back one day. Maybe I'll be back to real London, or to knock off London. I don't know. We'll see. We'll see how it goes. Anyway, I hope to see you again tomorrow for same math time and same math channel. Anyway, stay safe out there. I hope to see you again tomorrow.